Hello, everybody. It is a pleasure to meet you. My name is Jorge Rodriguez, and I am an invited professor from Mexico. Here I am to explain you the importance of managing your projects under a design process. A design process is crucial to get outstanding results in your engineering projects. So let's begin. The first thing we need to understand is that solving is our duty. Actually, I am not an engineer, I am an industrial designer. That's why I have identified the importance of applying a design process into the engineering process, So, because solving is our duty, something that happens, we are going to call it a phenomenon. A phenomenon always is happening everywhere because of circumstances or factors. Those things that we call phenomena give us a problem or a need that need to be solved somehow, in some way, okay? The components of any solution is divided in three different worlds. The first one we need to understand its utility, okay? So when we detect a phenomenon happening, that phenomenon we need to identify if it is a problem or if it is a need. And we need to identify the purpose of the solution we need to bring to solve that problem or to fulfill that need. Okay? So, how does it need to work, or what does it need to do to accomplish the purpose? That is its utility, the utility or the purpose. Okay? Secondly, the solution needs to be feasible also. Why? Because it needs to be functional, producible, assemblable, and affordable. In third place, also that solution needs to be effective. What does it mean? It needs to work with efficiency and with efficacy. Efficiency means that it needs to work with the less amount of resources. And efficacy means that it needs to really deliver results. It means it needs to work. Also, it needs to be reliable. Why? Because it should work safely during long periods of time. And lastly, it needs to be profitable. It needs to have a cost-effective maintenance. The less pieces and the simpler the solution, the most effective is going to be, or we are going to have in our solution. Okay? This is a 3 stages design process. I call it the Vortex design process, and I will tell you later why. So to achieve an effective results to our objectives, a design process must be applied. Let's start explaining since the beginning this process. The first stage of the design process is actually understanding deeply the phenomena that is causing that problem or is showing a need. Okay? So we are going to intellect what is the purpose behind the solution. So we need to produce a solution to fulfill the need or to solve the problem, right? In this process also, it's important to understand the complexity around that phenomenon. Okay? Why the complexity? Because there are many things around that phenomenon. Those things are circumstances or factors that are causing that problem or are showing that need. Okay? In order to really understand that information, we need to map that complexity. Okay? Mapping a complexity is going to give us the first portion of a structure to really understand what we are going to do to tackle in the right way the engineering project. Okay? So defining the purpose is the first stage, and understanding the complexity around that phenomenon is going to give us enough information to start the project with the right foot. So remember that applying the right design process to achieve the right solution starts for understanding. That's why the first stage is the intellection. So imagine this chart here, this fractalic chart, is how a project behave during a solution, okay? So every single project starts with a fuzzy front end. What is a fuzzy front end? Is that foggy environment we face when we are going to start tackling a project, because there is no understanding. There can be too many ways of tackling the project. So that's why we call that the fuzzy front end, because we cannot identify exactly how we are going to tackle the project. So imagine this is the opportunity area. The opportunity area is exactly in the center of the phenomenon. So we need to understand, as we said, the circumstances and the factors around that phenomenon to really identify the path to follow to solve the project. But first of all, we need to identify the right door we need to open to tackle the project with the right foot, okay? We need to make the step with the right foot. So this is the phenomenon. The phenomenon causes a problem or shows us a need, okay? And in order to get the solution, a design process needs to be developed. Let's start with this. Remember the fuzzy front end. This is the opportunity area. We need to first understand, and after that we need to ideate, make an ideation, a brainstorming, in order to start getting the solutions, and after that, after many solutions, we can start making or getting the architectural solution, okay? This orange process is, previous to start the engineering process. This is most of the common mistakes that we as designers or engineers do during a process solving, as a solution solving, because we want to tackle immediately the engineering ideas and we want to convert them into a project before they start understanding everything around that the purpose of the solution we want to tackle, okay? So in this first understanding, we need to try to ask some questions to start getting solutions to understand that phenomenon. For example, what is the purpose to fulfill, as I said already? Who and what is involved in that phenomenon? Where and when it's happening, that phenomenon? But also what resources are needed to achieve the solution? Asking these questions that we call the key questions is really, really important. When we start the ideation, ideate all possible ways to fulfill the purpose, it is important. We need to make a brainstorming to produce as many ideas as possible previous of start doing some prototype, okay? Because we need to achieve the architectural solution. We are going to explain later what is an architectural solution. So, sketching out as many ideas as possible, make quick prototyping of the most valuable concepts, make an analysis of its performance, and start all over again, until achieve an effective solution. So this process is really important, and here is when the Vortex comes through, okay? I will explain later. After that, the architecture is the final configuration of the best concept you have produced and test, okay? That configuration is the beginning of the engineering process. So remember, previous to start with the engineering process, we need to design, and designing means the next. Normally, we understand the design or engineering process like a straight line, okay? So we have the research stage, the design development, and the design prototyping and testing, right? But guess what? Unfortunately, this method of solving engineering problems only works effectively when it is submitted under a rigorous corporative process. So what does it mean? That it only works good when you have a time frame and activities very well defined and with specialized human resources. So this process works in big companies because it's always managed by many people and it's also reviewed that every single stage accomplished its purpose, okay? But what happens when we have small groups of engineering or actually work as a solo, for example, normally to use this linear process, it doesn't really work because we are not rigorous running the process. A dynamic design process that we call the Vortex design process, because this is a vortex, this kind of a spiral is a vortex, is using the same linear engineering process that you identify research, design development, and design prototyping, but many times, So we shrink that process and we make the process in many loops, as we can see here. Okay, so doing this process many times make us understand and solve in the right way. So for example, let's focus on understanding. So remember, we have a problem, and but also we can have a need depending on the situation. So in this first stage that we need to understand that need, a phenomenon is originated by factors and circumstances, okay? And also can be something that is unknown for us, and but also is something that can be known for us. So if it's unknown, that need or problem to solve means that maybe we are going to create something for completely new, okay? But it's something known, it means that maybe it's already a defined project that we don't think we need to solve, okay? So these are two ways of tackling a phenomenon to get a solution. So if we remember that this chart need to trace or draw a path in order to really understand the way that how we are going to tackle the project, the first stage always is starting with the right foot. So if we overplace the spiral vortex over the fractalic phenomenon, means that we are going to reduce the possibilities of tackling or getting the entrance to tackle the project, and also we are going to trace our path in the right way. So this first round of the spiral is the understanding of the phenomenon. The orange ones are the loops we need to do in order to start solving and making ideation. Okay? So imagine this. This is our phenomenon. Okay? We have this ravine here with some kind of a stinky water maybe, and we need to make these people to pass through. Okay? It can be a problem, but also it can be a need to. Okay? So factors and circumstances are made with data. Okay? Let's see. The design process starts with understanding, right? We need to start solving and understanding through asking the key questions. Okay? So data should be discovered by answering the key questions. So remember that those key questions are: what is the purpose to fulfill? Who and what is involved? Where and when it's happening? What resources are needed to achieve the solution? So let's start. What is the purpose to fulfill? Well, do something so that people can cross over the ravine. Okay? What, who, and what is involved? Well, first of all, what kind of users are involved and which factors can affect their emotions. So here we have lots of different users, as you can see, and maybe those users are facing different emotions. Also, we have here a ravine with stinky water that maybe produces bad, it's stinky, it's bothering for people. Okay? The third question asks us about where it happens and when it happens. So we need to consider the location, the time of the day, and the season. So that solution needs to be thought in which place, in which country, in which region. So if we understand that, maybe we will be able to understand the weather normally is happening in that place, right? Also, it is going to be used at night or during the daylight, or it's going to be used when it's raining or snowing or it's making lots of hot. That's why where and when is very, very important. So where and when happens that phenomenon is going to give us information, data. Okay? What resources are needed to achieve the solution? Well, we need to understand the amount of economical resources we have. We need to understand the time frame where we need to make that solution. and but also which kind of technology we will be able to apply to build and design that solution. Okay? So unveiling the complexity behind a phenomenon is finding the right data through understanding and gathering information all around the phenomenon related with circumstances and factors to give structure to a universe of gathered data to decipher the nature of a need or a problem and to be able to find a solution. So in order to map that complexity, we need to make a mental mapping like this one. After answering the key questions through the right analysis, the gathered data must be identified and acknowledged, separated and organized, categorized and prioritized, and developed and analyzed to modulate, to be able to modulate something with all that information. But this is organization, right? We need to organize all that information. How we can do that? This is the mental mapping or the complexity map for the problem we have. Remember, the problem is crossing the line from one side to another. We know already many things. We are going to review it that little by little. Let's start. Here we have this tool. The name is Lucidchart. Lucidchart, it's a tool that you can find over internet. It's a web application that is really useful to make mental mapping and to put all your ideas into something that can give you the structure to start thinking in the right way. So, what is the purpose to fulfill? We already know that there's something to make people cross from one side to other. We need to somehow pass over that ravine with stinky water. Okay? After understanding circumstances and factors involved on the possible solution, a detailed purpose definition must be written. So, at the end, we will need to write down a purpose definition, a very detailed purpose definition, because that will show us all the requirements that are going to be needed to design our solution. So let's start with the where and when it's happening. So this is a sample, okay? Just for you to understand what I'm doing. So remember, understanding what level of data can be useful to find out the requirements for the project. Select the graphical region, country, place, and imminent context. So to speak, let's say that we are going to build that in Alaska. But besides this, we need to keep, spreading and looking for more detailed information. So Alaska, okay, but which kind of region in Alaska? What is happening in that place in Alaska? It snows always or once in a while, or what is happening? It's gonna be a dangerous place or it's gonna be an easy place, so on and so forth. So you will need to keep fulfilling of information in this side with more detailed information that can give you more clues. Okay? For example, understand the time of the day the product will give the service. So in this case, for example, that bridge, so to speak, can work at night and during the daylight. Besides, we need to understand the geographical region and context. Understanding that we can deduct the kind of weather and climate conditions where the product will work. So it means that we may do or design our bridge, it needs to be covered and closed. It needs to have automated lighting. It needs to have heating control because it's going to be snowy because it's in Alaska, Need to have ventilation maybe, water and snow proof, also windproof. So these are some kind of features or requirements that are going to show us, the way we need to make solutions or produce solutions. So for example, also these first stages of information can give you more information like this one. This is a sample. It may have autonomous doors. Why? Because need to have covered and closed. So in order to maintain heat inside, automated doors need to be maybe installed on that thing. You know what I mean? And also you can start spreading out, more information like what kind of automated, if those automated things are going to have sensors, infrared sensors, or maybe lighting sensors, whatever, so on and so forth. What kind of mechanisms they are going to work. And so we need to start understanding what companies do, automated doors, so on and so forth. So these kind of mappings, the more information we can spread out, the better, because our understanding is going to be deep. If we run through this other question, which is who and what is involved, let's focus on the people, which is going to be involved. So only pedestrians, no transports. Okay? So this is our requirement, only pedestrians. What kind of pedestrians? Handicapped, overweight people, maybe people over 60, which will demand, more accessibility, or it needs to be more safe, because it maybe need to have ramps or handicap equipment. Okay? Maybe also pregnant woman with childs, another kind of people, which other people, it is this one. If we can find out, it's gonna be really good. So what does it mean? That the conditions we need to bring inside of that bridge need to be safe, accessible, and easy to use. Okay? So we can keep, spreading out information like this one. Anti-slippery floors, ramps, handicap equipment like handles, for example, need to be comfortable, so on and so forth. So the more information you can spread out, the better. What is involved? Remember, who and what, okay? It is involved this a 9-meter depth ravine with stinky water flow. So we need to make somehow something that the people which is crossing over avoid smell this bad water flow every single time they cross. That is why it needs to be closed, right? Finally, this last question, what resources are needed to achieve the solution? It means like the kind of solution will need to be figured out according with the amount of economical resources we have, okay? And the development will rely on the economical resources and the technology involved. So, depending on the amount of resources we count on, okay, if we have a very small amount of resources, we need to design something with that. Maybe, if we have a small amount of resources, automated doors are not going to be possible. Maybe, But if we have a good amount of resources, maybe not only an automated doors can be worked, also maybe cameras, safety cameras, and sound, and other kind of features can be added into our solution. So because those kind of things are related with safety, and but also with comfort. Okay, so how can we make that journey inside of that bridge comfortable? Okay, having the right temperature, listening some kind of soft music, maintaining that thing clean with materials that can really give us comfort. So if you see, trying to solve these kind of maps give us data. That data we are going to translate it into requirements. Those requirements are the key to start designing our product through ideating many ideas as possible previous of getting the last result. Okay? So once we understood all of that, a detailed purpose definition need to be done. After understanding circumstances and factors involved in the possible solution, a detailed purpose definition must be written mentioning the detailed requirements. So this purpose master definition need to have all the details that we already analyzed in every single portion of the map, and the more information we can put in this master definition, we will be able to identify all the requirements that are raw matter to start the conceptualization of our solution. The second stage of the Vortex design process is actually the design engineering phase. Okay? Why design engineering? Because we are designing, but also we start thinking in engineering. We are going to making a crossover between those two concepts. Okay? So the first stage in this second design Vortex stage is the architectural configuration theme definition. But what is the architectural configuration? When we are talking about an architectural configuration, it don't mean a design, It means the group of features that are going to be assembled to produce a design. Okay, so what does it mean? We need to accomplish something, in the case of the bridge, that with some kind of a structure, the most efficient structure, can go from one side to the other, and also can have the possibility to be closed, and also can have the possibility to have all the different requirements and features that the master definition is telling us. Okay, but we are not designing in detail right now. We are just making lots of different proposals in the most simpler way. Okay, after doing this, we are going to freeze the best concept to start developing that best concept. So here it is. We are going to use the same linear, but shrink it in every single loop. So we have the first stage, which is understanding all the data around that phenomenon. We are going to start, thinking, in this stage here in regards the design development. And this design development means the first stage of ideation. We need to produce lots of different ideas. And after that, maybe we can make some prototypes, In the case of this bridge, maybe we are not gonna make big prototype, maybe we can have, small prototyping or CAD prototyping, so to speak, to start trying out, okay, in scale. So every single time we go up again, we make the ideation. So we understand, we ideate, we analyze, and we start all over again. If you see, in every single loop, you are getting closer to the solution until you arrive, you get the best and the most efficient concept. Okay? So what ideation means exactly? Sketching out as many ideas as possible. So you may say, I am an engineer, maybe I am not good making drawings, It doesn't matter. You can do it whatever you want or however you want, But if you are studying right now, practice drawing, believe me, your skills of communication and getting ideas is gonna be bigger, because sketching out is a thinking skill. Okay, so if you want to really improve your thinking skills, sketching out the best way as possible is one of the right ways of doing thinking. Okay, so in these first 3 loops, we are going to have the architectural configuration, the theme definition. So that's why we have here lots of different ideas that we are going to be narrowing down little by little in order to get the architectural configuration signed off. So we are going to choose the most appropriate, the most effective solution that accomplishes or meets all the requirements under our master definition. Okay? Once doing that, we can proceed to architectural configuration development. Okay? So when we go to that development, detailed solutions are going to be starting. Okay? So this first stage of designing is just to get the main architecture or the main configuration of the product. Okay? In this case, the bridge. Once we exactly know how we are going to do it and what is going to be the concept, we can start defining materials, processes, assemblies with screws or welded or maybe through rivets. But anyways, with different strategies of assembling whatever, so on and so forth. So after that, let's say that this is the architectural configuration sign off. So we finally understood the money we have, the time we have, the technology. We understood all the people which is going to pass over, and also we understood that we need to go over the this ravine. That's why maybe we are going to put that stinky water flow inside of a tube. Okay, so once we checked all those things, it means that this is our architecture. And also, if you see here, we have ramps, for handicapped people, maybe for people over 60. This is our architectural configuration development. So we maybe are going to be developing many different structures. Maybe this is the most simpler, the cheaper, and the most effective ones. If you see, we add some handles, and the bridge can have in one side ramps, but in the other hand we can have stairs. Also, we put all that water inside of a tube. That's why we are gonna avoiding, to have a stinky situation. Okay. And at the end, we can start doing our engineering process. So this is our concept. But how we are going to assemble this structure, what material we are going to use, how we are going to install it, how we are going to put these handles, what size are going to be these stairs, what is going to be the slope of these ramps. All those things are engineering that we need to apply. So that's why we can start doing some kind of computer-aided engineering to make analysis, to make simulations. Also, we can right now start prototyping, making some ideas that improve. We need to apply DFM and DFA. I don't know if you are familiarized with these terms. What DFM and DFA means, that design for manufacturing and design for assembly. Okay. Also, we need to understand its feasibility to diminish the amount of costs as possible. And after that, we may do the failure mode and effect analysis, which means that we need to think in all possible situations that can make that bridge fall down or break, for example. If we with that FMAE analysis, we will be able to prevent our design for disasters, for example, for an earthquake, or maybe for something else, for wearing, so on and so forth, in order to produce the final product analysis. And at the end, we can start doing the implementation, which means product engineering, manufacturing, and we need to know if this is going to be just only a single bridge for a single situation, or if we are going to face that situation during the length of that rubber is going to be 1 kilometer. Water flow is going to be inside of a 1 kilometer of tube. So maybe we will need to make 10 bridges or 100 bridges. So also this manufacturing strategy, the materials and the manufacturing technology need to be related with the amount of components we are going to produce. If we are going to have mass production, or we are going just to have a single production. Okay? Imagine that you are in NASA and you are going to produce only a single satellite, right? It's not going to be a mass-produced satellite. So the manufacturing strategy and the manufacturing production you will need to do, or you will need to think, is in regards of making a single piece. Okay? So once again, here we already accomplished this vortex passing through the architectural configuration, which is the design process. We understood, we ideate, we produce the architecture, and finally we got to the engineering process in the final loops in order to get the right solution. Remember, intellection, ideation of the architectural solution, and refinement and testing the engineering solution. And this is it. We were able to build this nice bridge in a very simple way, and people love it.
So this is it. I hope you enjoy this travel through the design process, and I hope also you learn something that can help you to improve your design skills. Okay? See you then. It was a really pleasure to be with you. Until the next.